Good evening, boys and girls. Today I'm starting off in your polynomial packet on page 20, talking about the factoring of the difference of two squares. So we do these separate because they follow a nice little pattern, and if you can recognize the pattern, it makes your life a little easier. So first, review of what a perfect square is. Okay, 1 squared is 1. So 1's a perfect square, 4 is a perfect square, 9's a perfect square, 16's a perfect square. Because I always think of it the opposite way this is written, because their square roots are whole numbers. So the square root of 16 is 4. The square root of 25 is 5, because 5 times 5 is 25, and 4 times 4 is 16. So you can figure out the numbers that are perfect squares. So if you have a perfect square, it's really easy to factor the difference of two squares. So if you looked at this binomial times this binomial, you can see that the x each have an x, they each have a 5. What's different is the sign. This one has a positive, this one has a negative. You'll notice that all the way down. A y and a y, a 7 and a 7, different signs. A b and a b, an 8 and an 8, different signs. So when you FOIL this, you'll see that when you FOIL them, these middle terms end up canceling each other out. So instead of ending up with a trinomial, you actually end up with a binomial. Well, when we factor, we go on the reverse. So if we took this and we wanted to factor it, we can see it's the difference. This is important. It's not the sum of two squares. It's the difference. So this pattern only works when it's the difference of two squares. X squared is a perfect square because the square root is x. 25 is a perfect square because its square root is 5. And then you'd have different signs. So it always factors into that pattern, which is the same as this pattern back here. Okay? So let's just try it. The first thing you have to ask yourself is, do you have the difference of two squares? So yes, it's a difference. Now let's see if they're two squares, perfect squares. Yes, they are. So you know it's going to factor into x and x. So the square root of x squared is x and x, or x times x is x squared. The square root of 4 is 2, or 2 times 2 is 4. And then 1 of each sign. Okay? So the next one, it's a difference. Two perfect squares. 49 is really 7 times 7. X squared is really x times x. And then different signs. Okay, the next one. I have a difference. 16 is a perfect square, and x squared is a perfect square. If 16 was a perfect square, but it only had an x here instead of an x squared, I couldn't do it. The whole term has to be a perfect square. And then 49 is a perfect square, and y squared is a perfect square. So the square root of 16 is 4, or 4 times 4 is 16, and then x, and 7y, and 7y, and one of them positive and one of them negative. Okay, and then if you want, you can FOIL them to check your work. You'll see the middle terms will cancel out because of the signs, and you'll be left with 16x squared minus 49y squared. Perfect square, perfect square, perfect square. Now be careful here. You think, oh, well, 6 isn't a perfect square. Well, when you're multiplying, you add exponents. So you can break 6 up into 3 plus 3 because you're really adding those exponents. So you're really looking to see if you can split this up into two numbers that will add to give you this, two of the same number. So this would be 1 and 1, this would be 4 and 4, this would be 2 and 2. Because remember, you're adding those exponents. So there is, I guess, a little bit of a trick to it. So 36 would be 6, a squared b to the third, 6a squared b to the third. 6 times 6 is 36. A squared times a squared is a to the fourth. B to the third times b to the third is b to the sixth. Minus, I should have made more room. I'm going to have to rewrite. I didn't make them big enough. So let's try that again. leaving some more room. That's better. So I've got 6a squared b to the third, 6a squared b to the third, minus 8xy to the fourth, plus 8xy to the fourth. Okay. Next one. Don't get all nervous. Perfect square, perfect square, perfect square. Difference. Perfect square, perfect square, perfect square. Okay. So we're just going to do the same thing that we've been doing. So, get your parentheses set up. So that would be 6, 6, 7, 7, x, x, one of each sign, 8, 9, y, 8, 9, y. Okay, and now just to make sure, let's FOIL it. 6/7 x times 6/7 x is 36/49 x squared. 6/7 times negative 8/9 is going to be negative 48/63, and x times y. And then a positive 8/9 y times a positive 6/7 x gives us a positive 48/63 x y. And an 8/9 y times a negative 8/9 y gives us a negative 64/81 y squared. These are like terms with different signs, so they actually cancel out, leaving you with 36/49 x squared minus 64/81 y squared, which is what we wanted to get. Okay, if you need to replay the video, replay it. Remember, first thing you do, make sure it's a difference. Then make sure you have perfect squares. And then just split them up. I want you guys to do this middle row. So 2, 5, 8, 11, and 14. Those are the ones that you want to try. Notice 14 looks a little different. So think about what to do for 14. Maybe use some of your prior knowledge from a previous day's work and give it a shot. Okay, we'll see you guys in class for practice. Have a good night.